Guess what I've done this time, Stewie? I've written the fastest sorting algorithm the world has ever seen.
Is that right, Chris? How fast are we talking?
I don't know. It sorts a list by checking every element against every other element.
Oh boy, here we go again.
What do you mean? It works perfectly.
You've written bubble sort, Chris. It's a very common and well-known algorithm. It can be useful, but it's definitely not the fastest.
Chris, for goodness sake. Do you know about Big O notation and time complexity?
Not really, Dad. I kind of fell asleep while they were explaining it in class.
Chris, you need to stop doing that. Listen to me. Big O is a notation we can use to evaluate how many steps our function will take in memory. We use it to measure how our code scales with bigger inputs.
I have no idea what that means, Dad.
It's okay, Chris. I am here to help you learn. Your algorithm is fine for sorting, for example, 10 items. But what if you had 10 million?
It would probably be pretty slow. So what's this Big O thing, and how does it actually work?
Okay, so imagine we have 10 elements that are already sorted perfectly. If we run your function, we will only need to do 10 checks to see that this is the case. 1 for each element. This is known as the best case scenario. For this algorithm, the number of steps we have taken is equal to the number of elements we have. We can write this as a best case time complexity of O(n). The number of steps equals n, the number of elements. Does that make sense?
I think so, Dad. And what about if the elements are not sorted at all?
That is my next scenario, Chris. Imagine that we have to swap each element every time. We would ultimately end up swapping 10 elements 10 times. This is known as the worst case scenario. Since we swap n number of elements n number of times, the worst case time complexity here could be written as O(n) squared.
Oh, I see. So for 10 elements, it would be 100 steps in total.
Yes, Chris! You're getting it now! O(n) squared is like trying to sort a deck of cards by comparing every card to every other card. In other words, it takes forever.
Okay, Dad. But my function will still get the job done, right?
Yes, Chris, but so does a horse. And yet, we have cars. Let's imagine you had 10,000 elements. That would be a worst-case scenario of 100 million steps.
How long would that take, Dad?
It would take forever. That's like trying to find a single Family Guy cutaway by watching every episode from the beginning.
I would totally do that, though.
That explains why you keep falling asleep in class.
So what sorting algorithms are better, Dad?
Ever heard of merge sort and quick sort? They use different techniques to break the problem down instead of brute forcing every comparison.
Stewie is correct. Divide and conquer. Merge sort has a time complexity of n log n, which is better than n squared. I can break down individual algorithms for you later. But think of them like cutting a sandwich in half instead of taking one tiny bite at a time.